Okay. Okay, so what I have here is I have a light bulb, and I've extended the ends of the light bulb with these two wires. And we know that if we connect the light bulb to a battery, we know that the electricity flows in this loop, kind of like a racetrack. Okay, so a circuit is a loop. It's a circle. So electrons go from the battery through the light bulb, out of the light bulb, back into the battery, and we let that go on and on and on until the battery is discharged. In other words, the electrons are rearranged inside the battery. Okay, we don't lose any electrons. Okay, this is all self-contained. It's a system. Now, the reason this lights up is because there's current going through that wire. A light bulb, it just has a very thin wire, and the thinner the wire, the higher its resistance. And if we have a lot of resistance, what happens is you get a lot of heat. And if there's a lot of heat, the heat actually causes the wire to glow. And if it's glowing hot enough, it's a white glow. So that's how an incandescent light bulb works, as opposed to a CFL or compact fluorescent light bulb. Okay, so how can I make this brighter? Okay, this is the key to your understanding. Okay, I want you to be able to answer that question. So how do I make that brighter? What do I do?
Add another battery.
Add another battery. And if I take another battery and add it to this, what's like to make this brighter, what has to happen? I need more current. So how do I increase the current?
Introduce another.
Okay, so if I do the battery in parallel, what will that do?
Nothing.
Why not?
Because it's not
It's
connected.
not attached.
No. Okay, so now it's attached. So you see nothing happened. Okay, so this is a parallel attachment. So the negative ends of the batteries are connected to the red, and the positive end of the batteries are connected to the black. So this is just the fatter battery. So this will last longer because I got more chemicals available. And I can take a third one. Still as bright, but it'll last even longer. I don't know, maybe twice as long, maybe 3 times as long. You know, you would have to experimentally determine that, but that would make sense that, you know, 2 batteries, twice as long, 3 batteries, 3 times as long. But I haven't changed the voltage here. This is still 1.5 volts, parallel to 1.5, parallel to 1.5. So the amount of current in the circuit is the same because of the way it's connected. Okay, so you said earlier that I need to connect them in series. Okay, so if I put the 2 batteries in series, that increases my voltage. So 1.5 plus 1.5. And if you increase voltage, how does an increase in voltage affect the current? Increases. See, the resistance hasn't changed. The light bulb represents the resistance in the whole circuit. There's only one light bulb, only that limited resistance. So this goes brighter. Okay? And what if I add a third battery?
It's even brighter.
Should be even brighter. Okay. Oop. There you go. Bright, even brighter. That connection. Even brighter. Okay?
How bright can it go?
That's 2 batteries. That's 1 battery. 1 battery, right? These are just there, but nothing's going through it. The current is going from the battery, through the bulb, back into the battery. These are just bypassed. Current goes through from the battery, through the bulb, through the bottom of this battery, through, and then continue. In a loop, like a racetrack, cars going round and around and around. Same thing here. Now it's going out of the battery, through the bulb, back into this one, and this one. There are now 3 batteries connected end to end. The more batteries end to end in series, the higher the voltage, the higher the voltage, the higher the current. That's what Ohm's law tells us. Okay, I is equal to V divided by R. Okay, so what if, so you saw what happens when I increase the number of batteries. What else could I increase? We want to learn from this and then talk about.
Number of bulbs.
I can increase the number of bulbs. So if I increase the number of bulbs, okay, so let's disconnect this. I'm going to increase the number of bulbs in series. So out of the battery,
That one battery disconnected.
out of the battery, through the bulb, out of the bulb, into the next bulb, out of the next bulb. Okay. So I guess you have this on video, so you can always go back and compare the brightness. But do you recognize what happened to the brightness? Yeah. What I could do is I can take this wire, look how I do this, and think about the racetrack. Racetrack starts at this battery. Oops. Those are the connections, that's all. Don't worry. Okay, comes out of this battery through light bulb 1, through light bulb 2, back into the battery system. Okay, so now I'm going to take this red and I'm going to connect it right here. That's obviously brighter. One bulb brighter than two bulbs. Now, I want you to explain, like you still see the green wire there, okay? How come that light bulb isn't lit up right now?
Taking the
It's a
shoulder.
shorter path.
Yeah, we've taken a shorter path. We've actually bypassed that light bulb. That light bulb is not part of a loop. So there's nothing going in and out. Right now, I guess the way we've been following there's an opportunity for electrons to come out of the light bulb, but no electrons can get into the light bulb. Okay, but if I take this red wire and connect it here, electrons go from the battery into bulb 1, out of bulb 1, into bulb 2, out of bulb 2, back into the battery, into our racetrack. So we have one racetrack here with two restrictors. That's what the batteries are doing, or resistors. That's the proper term. But they're restricting the flow or resisting the flow. And again, Ohm's law tells us that I is equal to V divided by R. So if we increase R, we decrease I. So right now, there's a less, is that right?
Yeah.
Did I say that
The
right?
voltage is constant.
Okay, the voltage is constant, okay? And we definitely increase the resistance, so we don't even need this thing. We can use the brightness of the light bulb to say what's going on. We can, of course, prove it. Maybe we should. So let's set this properly. Now, the AP program doesn't ask you, how do you use a multimeter, just how do you use a meter. So I'm going to set this. Actually, I don't even know what the current is. My guess is going to be this. It's going to be high current. And what I'm going to do is I'm going to measure the current in the loop. I can put this anywhere, right? Because this is a loop, a racetrack with bumper-to-bumper cars. Okay, so they're all moving the same speed. I'm kind of equating speed to current. It's not really accurate, but it's close. It works. So actually, let's do this end. So I'm going to measure the current that leaves the circuit and goes into the light bulbs, right there. Okay, oh, this is working good. So this is 0.25 amps. 0.25 amps. There's 0.25 amps coming out of the battery, flowing through the meter. Current flows through the meter as opposed to voltage. Out of the meter, into light bulb 1, out of light bulb 1, into light bulb 2, out of light bulb 2, back into the batteries. Okay, so that's the current. So now let's take this connection here and light up only one battery. More current, and it's brighter. There's the dissociation. Okay, so you should have the ability to explain what should happen if I manipulate these wires around. Okay, what happens if I add more batteries in series? Increases the voltage. What happens if I add more light bulbs? Increases the resistance. What happens to the current as I change the number of light bulbs, or if I change the number of batteries? Okay, that's what the understanding that you need to have. Okay. Okay. So how about connecting in, the next thing would be connecting in parallel. Okay, so let's get rid of the meter for now. Okay, so let's just keep that bank of batteries. That seems to be working nicely. Okay, let's connect one light bulb to the batteries. We've seen that a bunch of times. Okay, that's good. Oops. Just want to make sure everything is visible in the video. Okay, you can see all the wires. Okay, so right now, is that series or parallel? Kind of neither, because there's only one thing.
Well, the
Yeah.
batteries are in series.
Yeah, but the light bulb, the resistors, there's only one resistor, so you can't really say it's parallel or series. Like, it's kind of meaningless. Okay, so what I want to do is I want to connect this one in parallel. So what I could do is I can connect both sides of, the two sides of the light bulb number 2 to the same bank of batteries like this. I'm doing that so you can recognize what's going on. And look, oh, they're the same brightness. What does that tell you?
Okay, it's the same.
The current coming out of the batteries is the same? Is that what that says?
No, it's
For each battery.
For each light bulb, it's the same. For each light bulb, it's the same. So if the brightness is the same in here, it's almost the same. Changes a little bit.
Well, if they
Okay,
each have
just
the-
ignore the little difference.
They each have the same resistance, that means they have the same voltage too.
And they have the same voltage, yeah. And the reason is parallel components always have the same voltage. And we can measure that. How do we measure voltage on this light bulb right here? What do I do?
No, you can
No,
just
you
touch
have
the
to-
top.
Here, I have to do this. I have to touch it here. Okay, in other words, I don't have to open up the circuit. When you use an ammeter, you have to open up the circuit. When you use a voltmeter, you close it. So let me just finish off by doing this. What I'm going to do is I'm going to connect the meter
Max, please report to guidance.
like this. How come that's not working?
Is it not connected?
This
You have
is
to connect the,
to what? Well, one of them should have lit up. Ah. Okay, there you go. Okay, so look at the current.
Have your attention, please. Will following
I
students
think the current
So-
inside of the video.
No, it's in the video. Okay, so the current is 0.35. Now, when I take the second light bulb and I connect it right here, so it's in parallel, the current goes up, it doubles. The brightness stayed the same. Why did the brightness stay the same? Because more current came out of the battery system to feed each light bulb. Okay? So, use your understanding of brightness to explain current. Okay?